So now we're recording. But yeah, that's something that you and Arian, either separately or preferably together, need to come in and talk to Dr. Bering about, because since y'all are kind of waiting on the Javad to show up, I'm putting y'all on the figure out how to get the IMET-R to talk to the Arduino, and not just figure out how, but like make it happen. Have some kind of communication between the IMET-R and the Arduino and get even on-the-ground data out of it. That was my follow-up question, is do we have one?
I believe we got some new ones. There's a new version of the IMET that came out.
But did you get the R model?
I think that's what you're talking about, because we did have a newer version. I'm not sure if it's the R model, but I think
the R model, we need to be precise here. All of the IMET models have been updated to IMET 1, to a new version. But when you order IMET, in order to be able to put in external data inputs, you have to get the R model.
I can go check it.
No, you don't need to check it now.
Okay.
I mean,
okay, I'll check
we may have to order another one for August. He ordered 3, but he may have ordered just plain Janes.
And so Hamza and Arian, y'all are in charge of making sure that we have an IMET-R, and then making sure that it talks to an Arduino. Either one of the Unos that we have now will work, but how many? We have 1 mega on order. Diego, do you know?
We have 2 megas on order. They shipped on the 4th.
Cool. So they should be here.
I would like to say
relatively soon.
that I would really like if somebody can have both written instructions, which I guess I'll get by email, and one set up and ready to work by 2 o'clock on Monday, so that I can conduct an actual class instead of an exercise in frustration.
Will we have them by Monday?
No. I mean, we have the one that
the Unos.
We have the Unos.
All right. So Hamza has an Uno, and where is the other Uno?
It's upstairs. I mean downstairs. Sorry.
All right. So is there a reason you work on that in Leper's lab instead of in the lab over there?
Most of the time I'm up there because I'm working with my ozone sondes also, because I'm kind of working and doing this at the same time. So I'm checking my ozone sondes and running the machines and stuff like that while I'm there. And then I have this computer, and I have area and space, and I have Wi-Fi and everything. So yeah, and then I have the workspace there too, so I can, if I have to solder and everything, I have all the equipment in there. So.
Okay. Well, just for whenever you leave today, or just to have it ready for Monday, make sure that it's, I guess, on Dr. Bering's desk.
I don't have access to Dr. Bering's. And besides, it needs to be set up here for class. So, I'll be here to come in and.
I'll be here Monday also, so
okay.
Well, but Hamza's the one who knows how to fix this, and Hamza also has offered to donate his Uno for the class purposes. So one of them should be set up, and let's make sure it's working by like 10 or 11 o'clock in the morning.
Well, Hamza won't be here because you have work on Monday, right?
Yeah, but if he leaves his out here, then I can cook.
All right. So do you have your Arduino with you, and are you going to bring it to school when you come in, Hamza? Yeah. So just please leave yours here, and yeah, that'll be helpful.
Email me those instructions, because I'd rather instruct than beat my head against the wall.
And also work on the Uno that we have here that either is or isn't working. So how many ever Arduinos we have that aren't working, try to make your fix make them work, and then leave all the Arduinos that we do have on this table in this room right here that we're in now.
Where's the static shield guide?
I have no idea. Like? It's black. Looks like plastic, regular plastic.
Probably something we need to, because I don't even know.
It probably got thrown because nobody knew what it was.
Okay. Right, so there's the August first week of August validation flight and all the craziness that goes into that. That's kind of what we just finished discussing. Hamza and Erica had a question for y'all about which batteries are we most likely to use, but since the time I wrote that question down, it's become less urgent, and since we're already 35 minutes into the meeting, we'll skip it for now and we'll talk about it later.
Okay, well, just real quick answer. I haven't picked the transmitters, I haven't picked the batteries.
Okay. So I've been pushing Asana a lot more. It's kind of how I'm trying to manage people from Bay City. Does anybody have positive or negative feedback about it? Good things, bad things to say? Is it working for you? Are you running into frustrations about it?
I forget to check it.
Yeah.
Right. And so I've kind of been nudging people towards using it because it gets more useful the more you use it, right? So it's like Facebook. Facebook's not very useful if no one's on it. But if everyone's on it, then it's the most useful thing on the face of the planet. And Asana's a lot like that in its operating method. So the more you have it open and the more you go, as you're thinking through your thought process and you're like, oh, I need to do this later, and you just type it into Asana, put a due date on it, and put your name on it and whatever project it needs to be in, it becomes a very useful tool in that aspect. And if you're logging in every day and you're checking, do I have new tasks or do I have upcoming tasks? What was I doing yesterday? I don't remember what I'm supposed to do now that I've gone home, I went to a party, slept, and then now I'm back at school. Where was I yesterday? What am I supposed to be doing? Oh, I have this task list that I put up in Asana, and I can check it off and go, these are the things I need to have done by today. So that's kind of the way you should be using it. Anytime you're sitting down to work on this project, 90% of the time you have a laptop open, so make one of those tabs Asana. Which is asana.com, and use it. Use it to check off tasks that have been assigned to you, and use it to put in tasks that you think of that, like, hey, I need to do that. Or if you need to ask somebody else to do that, you can make a task and then put their name on it. And you can write in a description about it so that they know kind of what you're talking about, besides from just the title. But is there any more input about it? Do y'all like it? Do you not like it?
I just struggle with just adding tasks on my tablet.
Yeah.
So
Me too.
I'm probably just gonna end up bringing up.
Using it on the tablet?
Yeah, my iPad, because I swear I added something. You're telling me I didn't. I was like,
well, they might be there, but what I was thinking is that they didn't have your name on it.
No, I put my name on it. I don't know. I think it's being weird with the iPad. I have to do it on a computer.
Okay.
And I was wondering too, for Asana, can you like when it comes to tasks, like nothing, like I guess like not too much about the project, can you assign other tasks like in a different group or something? I don't know. Like I guess those tasks that are like a little bit different from an actual project, like towards the project.
Yeah. So
like for the homework thing, like I wanted to assign to everybody like, hey, do your homework, do my homework, but like I didn't know how to like not put it under the projects, like
like particle detector or something like that.
Yeah, like a different group, like miscellaneous tasks or something.
So did y'all hear any of that explanation? For some reason I got muted. I don't know why.
You were talking the whole time?
Yeah.
Oh my god.
Yeah.
I thought you were just like showing me. I was like, oh, okay, that's cool.
Yeah, I was talking that whole time. I don't know why I got muted.
A little embarrassing.
Okay. So, but yeah, what I was saying is, for something that you don't want to put in any of these particular ones,
Uh-huh.
you can go to My Tasks
Okay.
and then make it. And then when you put it into My Tasks, it automatically makes you the person,
Mm-hmm.
but you could go in and assign it to somebody else as the main proprietor.
Okay.
And then that would show up when you went to, because you can also look at tasks by people.
Mm-hmm.
So you can click on this guy and all of the things assigned to him will show up. And especially with things like homework and that you want everyone on the team to do, you can either put that in project management or you can put it in My Tasks. But really what I would suggest is, so something like this Arduino Homework 2, which is not a real thing yet, but it might be in the future. I was going to say go in and make, because if you need a certain number of people to do it, go in and make it separate tasks, the subtasks under the main thing, and then you click to add those people on it.
Okay.
So each subtask you could say, all right, you wouldn't need to name it John, you could name it Arduino Homework 2 and then put John's name on it.
Okay.
But I'm going to delete this because right now it's not a real thing. All the way. There. Okay. So that was definitely a good question. Does anybody else have any questions or comments about Asana? Problems? All right. I guess we'll go back to this. There's got to be a better way to do that. So this is summary of the schedule. Is talking more about the Fort Sumner flight, and then I'm still floating this idea, but I was thinking about getting everyone to do some kind of balloon flight in June. So going through the list and making sure that everyone has had a chance to launch something, even if it's an IMET, and just go out and do, because I know Erica and Dr. Leffer do a bunch of flights.
Especially in July. We're really big in July because the ozone goes up, so we'll be launching almost like every other day.
And I would like for everybody to kind of go through and really physically be out there and physically launch the balloon and put it up together and then look at the data and interpret it and write a small summary of what's going on. So it's like a teeny tiny test version of what your actual project would be like, minus you having to actually put together a sensor package. We would just give you something. Unless you already have one ready by the end of June, which would be awesome, and we would love to get you in an actual latex balloon test flight. Again, in case anybody didn't know, our final flight date is still scheduled for spring break, which is March 2015. And people who want ham radio licenses, you should know and have access to that flashcard database, and you should be studying it. And sometime in the near future, I'm going to set up a date for us to all go on the same day and take the test. We'll be able to take it multiple times, so don't worry if you fail it, but
try not to fail it.
yeah, just try not to.
First time go.
All right, so I'm going to go through, and now we're finally getting to the status update part. We're going to try to do it fast. I'll go first. I worked on the circuit diagram for the VLF and a lot of the antenna design today with Dr. Bering. I've done a little bit of the project management side as well, but right now I'm still very much in the antenna design part, but I'm hoping to be done with that by this weekend, and then from getting the antenna design, then we move on to the actual circuit design that would take the information that I get from the antenna and translate it to something that I could send down or send into the iPod that I would get on the flight. So that's mine. And then John, do you want to go next?
Sure. Me?
So what all have you done this week? Your mic?
Hello. Sorry, my phone is having seizures. Give me a second.
Okay.
Okay. So it says it's connected.
Who's going right now? Is it me?
You go ahead, John.
Okay. I was working on the lab jack this week, the analog to digital reading or computer with the factory software. We're still waiting on the sensors. What was it?
Sorry, go ahead.
All right. It's the analog to digital, and well, we were just reading the voltages for a battery just to test it out, but we're still waiting on our sensors. So once we get that, we're gonna hook it up to that and try to calibrate it and put it on the Moody Tower. And for the particle detector, I talked to Dr. Pinsky, and he's about to go on a meeting to talk about our particle detector, so he'll have more information on that. And he directed me to a site to calculate for the attenuations. And yeah.
Dr. Pensky needs those attenuation calculations from you?
No, he just asked me to look at it, but we're gonna go with a 1, because for the vapor deposition that we're gonna use, it's gonna be less than 1 mil. We thought it was gonna be either 10 or 2. But it's now less than 1. So he said if I want to confirm it, then I can go to that site that he told me about.
Okay.
I didn't hear a word of that.
You want me to repeat that, Dr. Bering?
No, it's a volume issue. I simply cannot hear that computer from here.
Okay.
Where I last heard, and this brings up a good point. At this point in time, guys, we should not be presenting me or anybody else with freehand sketches. We should be at the drawing stage. And by drawing, maybe you aren't hearing what I'm saying. I mean mechanical drawing. When an engineer or a scientist in this context uses the word drawing, they don't mean pencil sketch. They mean mechanical drawing, which means every line is drawn with a ruler, or if it isn't a straight line, the appropriate curve tracer. If you can do it quickly, use CAD. If you are slow at CAD, use a good pencil drawing. Tape down your paper, use a T-square, use a ruler, etc. John had a very frustrating interaction this week because he presented me with a copy of a hand copy of a pencil sketch done over the computer, in which no straight line was drawn with a ruler, and I misunderstood it completely. At this point, and the issue here is, and I have not heard what their decision was because I can't hear from here, was whether or not to use a 10 mil foil as their ultraviolet window versus a 2 mil vapor deposition coating. And I've been asking them for several weeks now to answer that question quantitatively by doing the attenuation calculation. what is the counting rate you expect, owing to unwanted ultraviolet photons getting through the window. And Daniel presented me with a drawing of how they would mount the 10 mil foil, but it wasn't anywhere near adequate to understand. In fact, I don't think the key parts were actually thought out. It was very conceptual. At this point, guys, your drawings need to be drawings, and when you're doing delicate things like installing a 10 mil foil, you need to have both the actual, this goes to the machine shop, fabrication drawing of the relevant parts, and in that case, an actual assembly procedure written out. You need to be at that stage with the timelines we have. And I think one of the things that's keeping you from getting to that stage is that you aren't sitting down and doing actual quantitative, scaled mechanical drawings. Because in doing that, you figure out how the parts are going to go together. What did they do the attenuation calculation? Would be my question.
Did we do it? No. I talked to him, and he said that they're going to vapor deposit it for the sensor already, so we're not going to have to worry about that.
Yes, you do.
I mean, we're not going to have to worry about,
you have to worry about it for two reasons. Number one, because I told you to worry about it. And number two, because if it isn't adequate, then you need to put a foil design together anyway.
But I'm saying that he's going to do that. Like whoever, because they have the whole package for the particle detector, and they're going to vapor deposit it when they give it to us already.
You're not understanding me. The issue is one of you, the investigator, verifying the design for yourself through your own design efforts. You guys need to learn how to do that and to do it properly. This is part of the learning process of this experiment. So, and the reason you need to do it is because I understand they're going to do the vapor deposition anyway. If the vapor deposition is inadequate, you won't know it until you get back junk data from your flight. You have to do the calculation anyway so that you know you don't have to build a foil window. You may have to. You don't know without doing the calculation.
Well, he pointed me to that site that has the whole tables for the 10 mils, 2 mils, and the 1 mil. So I will be looking at that.
Okay.
Dr. Pensky gave him a website that has a table with calculations for the 10 mil, etc., etc.
Okay. Yeah, the 10 mil we know is adequate. The question is, what?
Because he said for that, then the like 10 mils will actually be too thick for it. So that's why it's less than 1 mil. And he said if I wanted to confirm that, then that's why he pointed me to that website.
Well, I don't know quite what he's saying that 10 mils is too thick, because for 40 keV electrons, 10 mil has been the standard for 2 generations.
And that's what I had told him, because you told me that the other day. But he said that it would be less than 1 mil for what they're gonna make for us.
The fact remains is that for your learning purposes and for you can't rely on what a third party tells you. Part of what you're learning to do is design the experiments for yourself. And this is the attitude that it's driving me up the wall. You guys are all trying to do your experiments by shopping and by having other people tell you what to do without actually thinking it through for yourself. You got to do the work yourself. It's part of what you're supposed to be learning. It's an essential part of what you're supposed to be learning. So, you have to really sit down and ask yourself, is this web page right? And I don't know why you'd have to go to a web page. It's such a simple calculation, but you do need to take responsibility for yourself to make sure that what you're doing makes sense. Now I know for a fact that the 10 mil window is is transparent enough because it's what has been used. I got several students who wouldn't be PhDs now if it wasn't. But I'm very skeptical of this less than 1 mil vapor deposition thickness because they put that sort of stuff on the windows of skyscrapers and you can see through them. So I'm really sort of, wait, are we sure? We got to do the calculation for ourselves, at least on the thin one.
You said 10 mil was the standard for 40 keV?
40 kV and up, yeah.
KeV and up. Okay. So Hamza, go TEC.
Okay. We're just basically waiting on the receiver, and in the meanwhile, we're gonna start reading on the documentation. We have started already, but we're just gonna go more in depth, I guess, and then try and figure out how we can use the software that's available to get the actual TEC numbers. And then, of course, we're gonna work on the radius-on thing as well, I guess.
Yeah. Okay. And spectroscope, go, Diego.
I have a sort of wooden prototype of the telescope part set up. I need to mount the diffraction grating and a camera on it to make sure it works. And I already ordered the lenses I plan to use on the final build. I'm planning on going to like Home Depot or something to look for PVC pipe to see if they have available the kind of thing that I need to put up a casing for it.
Okay. Okay, cool. Let's go, Erica. Gaseous compounds. What have you done?
Okay, I ordered the sensor parts and everything for our sensors and the gas hoods. Everything should be coming in. We've been looking at a layout of how we want to set everything up. And we're looking at just calculating data rates and measurements for the sensors.
Okay. So I heard that the order for all of the parts and sensors and everything was 2,000. Do you know what? Was it like a big item or was it just a bunch of?
No, it's a bunch of little items. See, like we have our sensors, but we need the transmitting boards. Each board has to go for each sensor has its own board, so we have to order. We have to order at least for 2 U-pods we want to build, 2 to 3. So we had to order at least 2 boards per, and then we have the little gas hoods. The gas hoods alone were like $90 a piece. We need 6 of them. So there's a good amount of money there too. And then the boards themselves also cost like $90 to $100 also. Then the gas hoods, and then like this connecting part to put the hood and connect it to the transmitting board was another like $50-some, and then we're multiplied by 6. Add it up.
Okay.
Why 6?
Because we have the seal. We have 3 sensors, but we wanted to make 2 boxes, so we got 6.
Well, I thought you were somehow making 6 payloads. Okay.
No. It's 6 boards, 6 of everything, so we can make 2 of the U-pods.
And then Daniel Sierra, you've been working on.
Not much with regards to all that because Erica's going to take care of. And that's mainly the step we're at right now. So, but I guess mainly my part would be the thermal insulation of the actual package. And I've looked at that before. There's one material that I like, but if you want to especially order, you can't just really find it at like Google. So I kind of want to look at more of if that's possible. Kind of want to see how the board turns out, especially because I made I analyzed the old UPOD. Obviously, what I have for that isn't applicable to what we're going to build. So I have to come up with a new design. I was making the design for the dimensions, so I have to go back and do that. Um, we have a lot of foam stuff in the bouncer's lab. I wanted to look at that. I haven't got a chance to. I'll probably do it this weekend. Uh, to look at that and see if that's just a cheaper, I guess, free alternative. Uh, but I mean, the other stuff I wanted to look at was really good.
Okay.
But yeah, thermal insulation stuff. That's pretty much it.
He's in charge of the design of the casing and everything as well. So that's to make sure it's insulated.
What are your suggestions, Dr. Bering, for him to be doing when he doesn't have the thing he's supposed to be designing the casing around?
That seems to be a rather limited task, just designing the casing. Particularly since I thought most of what we're going to do is which is the usual approach. We certainly don't need to buy specialty materials to design the casing. Among other things, have you looked in the closet?
That's what I wanted to look at. That's what I said. Like we have some stuff here that might just be a free alternative if it's good enough.
I have rooms full of sheet styrofoam. And for $3 you can buy a styrofoam lunchbox, which is the normal method. So I would think you want to be working on something else significantly more serious than the casing. But what I would suggest is ask all the teams who's feeling the most understaffed. I actually know the answer, but I'm going to let you guys work that out. But I do think you should be engaged in more than material. That's a kind of a low-key task. Most professional payloads, that's kind of, well, first off, there's a standard material, period, end of story. And we get it from building supply houses, and I have a closet full.
Okay.
So I would definitely find the students to pick one. I'll tell you, I think that the coding is a lot bigger task than people think it is, particularly coding at the, see, when I'm talking about coding at the receiver end, I'm talking about, okay, you bring in a whole bunch of variables that the standard IMET doesn't measure. You've got to have a GUI, a widget, a graphical interface page.
A GUI is a graphical user interface
that displays those variables. That's quite a bit of coding, and it's fancy coding. And that's not running on Arduino code, that's running PC code. So you're presumably running, you're writing this in C and using some of the C graphics packages. You may be using the Windows or the Microsoft Windows library to drive Windows around. It's a non-trivial problem. So to me, that's the biggest task nobody's working on. Running Windows drivers is like, whoa.
Do you think that's something Daniel could work on?
I don't know enough about his skills.
Got it. But I mean,
do you think that's something he could learn? Do you think that's something that would be beneficial for him to work on individually? Essentially individually, right now, at this point anyway?
Somebody needs to start to look at that. I don't know about anybody's skills to know who's the right person.
You should meet with him later and talk to him and get a definite objective. What do you want me to do? In order, so look into something is not an actionable objective. You're like, okay, so what does that actually mean? But so just get in and talk with him. Are you going to be here next week?
At least get an idea of the layout of how we're going to build this GUI and stuff like that. I mean, if you can't build it, don't, but get an idea of how the steps to start building it and stuff like that, and lay that out so we can start attacking.
I mean, receiving a frame, there are a number of steps you could get. Talk to Daryl and get the free NOAA software, presumably since it's free and provided by the federal government, you can actually get the source code. You could look at the I have several examples, except they don't use Windows. They actually run under MS-DOS. But yeah, now that's a suggestion. Rachel, you are the project manager. You probably have a better sense of what might be useful for him to be doing than I do. No, let me rephrase that. You certainly have a better sense.
I would argue that that's not true, but we need to move on. So Arian, extrude files, go. Yeah, go ahead. Yeah.
So when they were meeting an app, to talk and do learn sterilization techniques and how to torture when we get down with the device. I'm gonna go home and fix this jumbo because I don't know what to think of this.
Oh.
If you can, don't take that home. If you can avoid it, keep it here. We want all of our stuff to stay in the lab and on campus and stuff.
What I was doing today was trying to figure out precise calculations on getting to the machine shop to get this into things or better to use it. We're going to talk to now. There's like a specific project. But for now, that's it. And, so the casing, that's after we get to the steel. But besides that, we're going to try to do testing next week.
So not Thursday? I asked you earlier if you were going to do testing on Thursday.
Yeah, next week. Well, I don't know.
Oh, okay.
This is what I have to do on Monday first. Because nothing wanted us to learn and do the simulation before we physically test.
Okay.
But this testing isn't going to happen. It's just going to be stationary for a couple of hours. We're just going to let it run to see what if it just stop in the middle and like the whole hours.
Yeah. They're just going to stick it on the top of the movie tower where all the calibration equipment and everything's running so that they can compare to the equipment that they're receiving the same levels and stuff like that.
Okay.
Yeah, if it works, then we just make
Good.
Alrighty.
This time looks better.
Daniel, did you want to say anything about particle detector or what you've done on Daniel Hermosillo on
Yeah.
either particle detector or gaseous compounds or both if you want?
Particle detector. Penske informed also John that he's going to a conference for these particle detectors, and he's gonna look at the new one that he might want us to see be flown, like for us to do. So he's gonna get a lot more information in this conference. He's gonna be emailing us once he gets more information, and then we're gonna contact some of his people that's done it with the Raspberry Pi, and we're gonna keep in contact with them. So if we run into problems, and we can ask them for help. And then I'm setting up tasks for Abdul, John, and I to work the Raspberry Pi since we're the ones going to need it, and how to get the data transfer, how to learn the code. Hopefully, you could figure that out, and also
Is there only one model of Raspberry Pi?
there's an A and a B, and then we're going to use the B, I believe, because it supplies 700 milliamps. If Abdul's still here, I believe. Oh, he left, but oh, he's back. Abdul? Well, I believe it provides enough for the particle detector, and we need I've been looking at the shield because when we handle it, we need to protect it from UV light, and then Dr. Penske just told us recently you just need to protect the sensor itself, so we just need a small shield for it. So I need to look into that differently now, and then. What else did you say? I think that's it. And then I've been trying to work this Asana thing with you, so that's it.
Okay. Dr. Bering has some comments.
Yeah, I mean, I guess I'm a little taken back by your last comment that you just realized that it was the sensor that needed to be protected from the ultraviolet. The which may explain why some of the drawings I've been seeing. Yes, it's the sensor that has to be protected. Now, I guess that's partly my fault. I thought that was clearly understood, that you don't get stray counts in a particle detector if you illuminate the box of the electronics with ultraviolet light. It's the sensor that's sensitive. But you guys really do need to start. I realize we're basically buying a sensor, but you need to start working the problem yourself to the greatest extent you can. Just doing what someone else is telling you is really not or consistent with the objectives of the project, but you're willing to learn how to do this stuff yourself. So doing the calculation of what you're going to get for a noise count rate with 1 mil of aluminum vapor deposition. See, at that thickness, that's comparable to what you have on some of the office building windows. And you can see visible light through those things. So I'm skeptical that that's thick enough. And I want to see the just relying on a website.
Couldn't you get like a piece of plastic and then just spray paint it in certain colors so that the light's not coming through from above?
Well, the plastic's going to also absorb all of the X-rays you're trying to detect.
Maybe not plastic, but glass or something. I mean, could you just paint it and
It's grams per square centimeter of matter total that absorb X-rays. So you really don't want now a 10 mil aluminum foil carefully mounted, and it's designing the mounting that's the problem, will work. The sensor can be vapor deposited with aluminum, and the question is that thick enough to give you adequate signal rejection in the wavelength between 40 keV and the point in the ultraviolet spectrum where the sensor stops responding. So you.
Okay. Abdul, do you have anything to say about Star Tracker or navigation or CPU?
Sure. So can you guys hear me?
Yeah.
Okay. So we ordered parts for the Radiuson, our navigation or CPU, code, everything else. So we currently ordered those parts, and the transmitter, I have been researching on that, sending a bunch of models that I could find that are suitable for our needs, and so we're at that over there on that part. With Star Tracker, I have so I have ordered parts, the Raspberry Pi, and I have few documents or few papers I'm referencing. Most of them, they're all either using a laptop for data processing on the fly, and some other ones are using FPG, field programmable units. So they're doing high processing. But with Raspberry Pi, I'm trying to jot down all the things I could eliminate in the algorithm, so it doesn't need that much processing. So I have came up with steps and wrote down steps how I would go about writing a code for it while I'm waiting for the hardware.
That's good. That's very good. Have you? Are you gonna come in anytime this week and talk about those steps that you wrote with Dr. Bering?
Sure.
Yeah, just send him an email and set up that meeting sometime next week with him. And when you get the time, set it up in the USIP Google Calendar.
Okay.
All right. Unless anybody has any questions or comments, I think that's it.
Okay, Chris and Abdul, I sent you guys an email of some transmitters. Just take a look of them for me, okay?
All right. I sent one as well. So
I saw it.
yeah, that's the one. I guess one of the balloon flights NASA used, and it's pretty powerful. But yeah, I don't know.
I think the only one problem with that one is it's still not the frequency we need.
What's the frequency we're aiming for?
We're aiming for 403 right now. As of right now, that's what I know, but I have to check with Dr. Leffler, but as of right now, 403.
Okay.
Uh,
We need to get all the parts we need for the long duration, long distance, high power payload test on order early next week because they should have been ordered a couple of weeks ago. This is taking way too long. I think one of the things that Erica could use is help shopping. That's another alternative for Daniel, is help shopping. She's floundering, struggling with the magnitude, but partly your shotgun. You need to get the things that we need done.
Dr. Bering, I have a question. So while we're shopping for the transmitter, does it have to be 403 megahertz or?
Does it have to be a 403 megahertz transmitter?
Yes, it does, because that's what our license is for. We have a specific license for an up to 3 watt 403 megahertz transmitter.
Okay, so it narrows it down and makes it that much harder to find.
I can't hear a word.
So he said that narrows it down and makes it that much harder to find.
Yeah. Actually, it should make it easier to find because it's a very specific product.
Yes, it's specific, but that frequency is rarely used for that high altitudes.
That frequency is rarely used for that high altitudes.
No, the problem is that they don't advertise transmitters at 403 because it's a license and because it's not for amateur ballooners. So when we do Google transmitters, we get everything else that's open and free, but the 403s we have to actually email the companies and ask them personally, do they have that, can they provide that, and then we also have to let them know who's asking, from where, and that it's not personally for us, and that it's part of the project, and da-da-da.
That we have a license from NASA for 403
all that
megahertz.
you have to explain too in the emails, or I don't get anything.
Phone calls are preferable, by the way, especially to vendors, because vendors don't respond to emails at the time that you want them to. A lot of these are coming from England.
No, I'm not calling from my phone.
At that point, you have to use the university phone. That one I found, the XM3 was okay. I mean, I just didn't have a price and weight, but it was a 403 and it was right there on the internet.
I know the XM3. I didn't really like that one. Well, okay, but I think for the late zero, the data rate modem would be this one, the RVM7U8. I'll also send it to you guys so you look over it.
All right, stop interrupting.
Sorry.
Okay, the XM3 comes right up when you search.
I haven't seen the XM3, not in the specifications that we
On
need.
Digital Network, I found it immediately. It came right up, and I showed it to you 2 weeks ago.
I saw it, but I didn't think it was good enough.
Okay, why? I mean, what I want is a PowerPoint with a table that explains why. Okay? I mean, and we need it. We need it ASAP. I was hoping that by now, on the 19th of May, my plan was that by now we would have the transmitter in hand and the Arduino Mega in hand. You guys are still not thinking backwards from August 2nd and saying, okay, I really need to get this done today because otherwise we don't get it done in time.
For the transmitter, I wasn't sure we were using high altitude as well.
What's that?
For transmitter, I wasn't sure if we're also looking we're also shopping for a high altitude transmitter that far from.
All of our transmitters have to be high altitude because they're all going to high altitudes.
Well, then we're looking for both. Actually, we're looking for one that's really high power and then one that's like it's okay.
The latex pressure is high, or the latex balloon is high altitude. Yes or no?
Yes.
It is, but when I talked to Dr. Leffer, we only needed to be 300 milliwatts and stuff like that, so it's not going to be as strong. We're going to need one transmitter for
Okay,
latex
you guys
and
are
one for
talking
them.
completely at cross purposes. They're all at high altitude, one low power, one high power. And the other thing we need to have settled pretty damn quick are the batteries. So if you guys need to fill in this table, then somebody, and maybe that's something else you might ask Daniel to do a complete battery plan. Somebody needs to do that battery plan.
That would be not
but-
wise, I think.
If we're going to have an Arduino talking to a transmitter by 2 weeks from today, we got to get hustling. And I think there's an attitude issue that we still haven't solved yet, which is, if I fall behind, what do? Work harder, work longer, get it done, get caught up. I'm not seeing that. Still not seeing that. And I think it's because you haven't really figured out how little time we have. Well, I need to get going. Anything from our completely lost soul?
Not yet.
Mm.
Alright, guys, good meeting, thank you.